Another example of invalid pointer references. In this case, you've already seen this code before if you had watched the video in Pointers chapter where we are returning pointers. In this case, the problem is X and Y are, it's the same problem that we had before. I'm just going to show you how it reacts in GDB on the server as opposed to what we saw on Python tutor. Okay, so different systems do different things, and you have to be aware of all the nuances of the different things, and you will get used to this as you work more and more with the debuggers. So we are passing X and Y. We're trying to get the minimum of two values of X and Y. So we're passing X and Y by value, and min is a pointer that gets passed by value as well. And if X is less than Y, we set the value of address of X to min, and then we return min. What's bad about this? X and Y are copies. The minute the function goes out of scope, X and Y are going to go out of scope, which means the returned address that's going to come back here is really not going to do anything. Even if you receive it, well, I'm not receiving it, so let's receive it. Even if you receive it, the address goes out of scope and there's really nothing that min will be pointing to. So if you try this out in GDB, and you saw this in Python tutor, if you don't remember, I'd go back to that section under pointers and try to watch that under returning pointers section. Okay, so here I have this code called badptrs.cpp, and this is the badptrs. Notice here we are receiving the pointer, but we are passing X and Y by value, and that means these are copies, and putting the address, even though they're called X and Y, right? I could have called it whatever else. It still doesn't matter. They are value parameters that are getting copied from here. So when this goes back, these two are out of scope. And so putting the address of that in min and returning it such that it comes back here is no good, because as soon as we go back there, these things have gone out of scope. But see what GDB does here. And this throws off people again, because it's not very consistent. So if you go into GDB and put a breakpoint, in this case, I'm going to put a breakpoint on line 13, which is where my function is, run the program. So it's now sitting in the function. Okay, and notice here are my parameters. X is 5, Y is 10, and min is pointing to nothing. So if X is less than Y, which it is, 5 is less than 10, we say min equals and X. And so let's see, what is and X? What is X point? X's address is that. What is min? That is min as well. So that's the right address. But then we're going to return it now. It's going to go back, and here we are in main, and if you print min, it has the same address, but this address is really not ours anymore. It's been released to the operating system. So it seems like it's working fine. Now notice it printed 5 for me. But then really, if you print min again, notice if you print star min, look at this large number. This is not the same as what we had before, because it's really not our address anymore, and it's been already released to the operating system. So your program may look like it works. So if you actually run this program, it will look like it's working, but it's really not working, because if you keep running this program a few times with that address, eventually that address will get taken over by the operating system for something else, and your program will go crashing because it's really not your address. So now it seems like it's printing something because it has some garbage address, but it's really garbage because it's not your memory anymore. The minute the function is done, the scope of this X and Y is gone. So it's really what your Python tutor showed you. Remember that picture in that memory that was garbage? That's really what it is. So don't be fooled by some of these and think that it's actually working. You might want to conceptually look at your program and see, will it work consistently every time, which it won't.